Hi everyone. Building Bitbucket pipelines on top of Connect platform gave us the ability to move fast. It also gave us the ability to dogfood or test while developing our own product, which has been invaluable in finding improvements. However, when we started, we were not in a position to improve it yet. And one particular problem we had was the presence of the spinner when loading all of the pipelines pages, which wasn't very satisfying. And so we tried different things to minimize it or remove it. To take a step back, let me briefly explain what is happening when this spinner is present. This spinner is present when the Connect add-on isn't loaded and authenticated. And so, firstly, the Connect iframe HTML needs to load. Then that HTML file needs to request the Connect client JavaScript library, all.js. When those two files are loaded and parsed by the browser, an event is sent back to the host product that, on receiving it, marks the add-on as trusted and shows it to the user. And in reality, this should be fast. I'm talking about milliseconds kind of fast, but this is not often the case. And so I was curious, how long does it actually take for existing Connect add-ons to go through this process? And so I looked at some data for Jira and Confluence for one of the recent weeks, and what I found out is that 55% of those add-ons during that period needed more than 1 second to load. And 10% of those add-ons needed more than 4 seconds to load, which, according to the research, is already frustrating to the user. While 1 second might seem like a not huge amount of time, you need to understand that this is just the initial step before any other data like images, CSS, JavaScript get even requested. And so that usually adds multiple seconds delay on top of that. And there are quite a few reasons there are quite a few reasons outside of our control, like slow internet connection or old handheld devices, cold cache, that might impact this number. However, optimizing loading of Connect add-on is the simplest thing to optimize. And so there are a few things we could do about it. And if there's one thing that I would want you to take away from this presentation, is to simply use CDNs. CDNs, or content delivery networks, like Amazon CloudFront, provide static assets faster by distributing them to different geographic locations, which might be far from the actual infrastructure that serves the content. For example, if your website is hosted in Ireland, but your customers use it in Australia, they would suffer from slow latency because of the distance. And so CDNs takes that data and puts that in Australian servers. That greatly improves the client experience. CDNs combined with gzip, which is often handled out of the box by CDNs, and gzip compresses your assets, reducing the payload size, really go a long way. And I hope this is something that all of you are doing already. And I would stop with the obvious and talk a little bit more about more obscure techniques that Pipelines is using to load its static assets faster. I will talk about how you could handle performance from 3 different angles in this presentation. Firstly, I will give you an overview. Firstly, I will give you some opinions, what you should be doing, should not be doing, and a few maybes. Next, I will give you a quick overview of ways you can measure the performance in order to assess whether it's actually worth optimizing. Finally, I will go a little deeper into Pipeline's Webpack configuration. And Webpack is a front-end module bundler that allows you to automate a lot of the optimizations that I'm going to talk about in just a minute. And I will finish with the current state of the spinner. OK, so let's look at some core performance optimizations and also things that you should avoid doing. In order to be able to benefit from the speed improvements that CDNs offer, you need to have the ability to serve static assets separately from your main application. And so you should decouple it. And the easiest way to decouple it is to serve front-end and back-end separately. And bundling your add-on to be used in a cloud in a distributed manner, the concept of single-page applications is currently considered as the most performant solution. Single-page apps also improve the speed of development as they allow you to develop and deploy your application separately, which promotes continuous deployment. If this is not possible, at the very least, you should consider putting your static assets like CSS, JavaScript, and images onto the CDN to achieve some of those performance benefits. HTTP2 is probably as important as CDNs. HTTP2 has been around for quite a while, but finally now is well supported by the browsers with good fallback support as well. And this is definitely something you should all be doing. But according to the current user statistics, only 15% of all websites are doing so. And you should be using HTTP2 for everything. By everything, I mean all the way through static assets, your application server, and proxies like CDNs. HTTP2 has several performance improvements on top of, compared to its predecessor, HTTP1. And most importantly, it breaks the HTTP1 anti-pattern where you were forced to combine and concatenate all of your assets that usually produced large bundle sizes and huge payloads. With HTTP2, you don't need to do that, and you could load all of the assets in parallel. And one of the other neat benefits of HTTP2 is the server push, where with HTTP1, the typical scenario might look like this. You request index.html, get the response, then that file contained additional requests that you'd make for CSS, for JavaScript, for images that you'd get in subsequent responses. But with HTTP2, you may only ever need to make one request to index.html, and the server could push all of the static assets. So that would greatly improve performance and rendering time. I will talk about how your client could notify which assets it expects to be pushed in further slides. OK, I could talk about the nice features of HTTP2, but I think it's better to show you this little demo. And what you can see is an example of HTTP1, HTTP2 version of a image that contains 180 small tiles. And you can clearly see that even though I deliberately slowed down the loading time of HTTP2 version, it still loads much faster. And this is much better experience to the user. In AWS CloudFront, enabling HTTP2 is as easy as toggling a switch in the web UI. And most of the other cloud providers have the same ability too, so it really gives you no excuse for not doing it. One of the main benefits of CDNs are those that they provide a caching service that is located close to you. Disabling or misconfiguring caching takes those benefits away, and so there are a few basic concepts that you need to understand about caching. And the caching I'm talking about refers primarily to pool CDNs like CloudFront that take care of fetching of the content themselves from the origin. And basically, the way it works, when you make a request to the CDN, they check if that request is already cached in the CDN. If it isn't, it fetches that resource from the server and stores it and delivers it to you. And if it is, it just simply returns you that cached value. And caching static content isn't a very complicated concept, but and it's also often handled out of the box by CDNs. But there are a few tools for handling dynamic content that is changing a little more often than the static one. And those primarily include ETAG and cache control headers, as well as invalidation tools. So ETAG header identifies the version of the document And usually that means that when you request a resource, it comes back with the header containing the ETAG value, for example, MD5 hash of the content that identifies this resource. But it doesn't have to be the content hash. It could be anything. It could be the version number. It could be date. It could be any string that represents the version of the document. And revalidation, the way revalidation works is that when your client visits the same, requests the same resource again, is sending one of those if-star headers to check against the existing value of the resource. And if, for example, if non-match, and if the ETAG header is matching the value that it has already stored, it returns 304 response non-modified, which simply means that depending on the ETAG value the client sends, it would get either the full response or a response indicating that the content didn't change. So it doesn't send you this data, which is also great for performance. Cache control header, as its name indicates, allows you to control the cache, and it consists of optional directives that can be divided into 3 main categories: cacheability directives, expiration directives, and revalidation directives. So cacheability directives contain of private, which means that the asset can be cached only in the browser. Public means that it can be cached in the browser or in CDN. No cache means that the content can be cached, but it needs to be revalidated before using the cache value. And no store means that the asset cannot be cached. Expiration directives, max age and smax age, simply allow you to set the cache validity time. So max age allows you to set in seconds basically means how long the cache location should keep the value in its cache. And smax age allows you to override that value and just for CDN, not for the browser. And finally, revalidation directives. Immutable means that the document won't change ever, and it can be stored forever. Must revalidate means that the browser always must check the status of the resource with CDN, even if it's cached. And proxy revalidate, which is similar to must revalidate, but the CDN always needs to check the value of the resource with the origin server. And so just an example how this might work. So by using those directives, you could control the cache in a way that you could cache it in your client and in your browser, for example, for 1 hour. You could say that, OK, you want to cache a specific resource for 2 hours in your browser, but for 1 hour on the CDN. Or you might want to cache that value only in the CDN or in the browser. And often you find yourself that you set a cache that you want to bust or remove. And there are 2 main reasons, two main techniques to do that. So cache busting means simply that it just circumvents the cache key, and that usually works through appending like a query parameter. So if you have like a URL foobar.tld some page, if you append the query parameter v2, it effectively requests the new resource, which isn't cached. So it gets the cold cache, and that circumvents the cache. And cache purging simply means to remove an item from the cache. And that might be done through, for example, CloudFront UI by creating invalidation on a specific resource. One of the techniques for performant UIs is to reduce the number of requests your frontend is making. Often this technique produces large code bundles, which, as I told you, with HTTP 1 becomes an anti-pattern. And so with HTTP 2, it's actually much better to ship smaller chunks of code and load them asynchronously. And I will tell you in a moment how you can do that with Webpack. This part is specific to Bitbucket and might be a little controversial, but I just want to give you an idea how thinking out of the box can speed up your Connect add-on or any website that you're trying to optimize. So in Bitbucket, the way the connect JavaScript client, the all.js file works, it's actually a shell script that requests another script from the CDN. And so when you request this file, it makes 2 requests, but you can change those 2 requests into 1 or even 0. So first, you could create your own all.js cache and periodically check for changes and invalidate the cache when those changes happen. Secondly, by looking at the all.js source, you would find out how this shell script works, and the way it works, it just passes the query parameters to request that file, and so you could construct that by yourself. And this is actually something that Pipelines is doing to remove that extra request. However, I would not recommend it because it's prone to changes, and it could potentially be quite dangerous. And the same goes for inlining the actual all.js, which actually would produce 0 requests, 0 extra requests. Finally, you could use service workers. And service worker is a fairly new addition to the browsers, and it comes in a form of additional JavaScript that you ship with your application, and it lives separately from it. So it runs in the background, and it could. And the nice thing about it is that it can intercept the requests, and it could cache the responses. So in theory, you could use it for caching the all.js file and preventing the request from being made. There are a few other interesting maybes, like GraphQL. So GraphQL is a query language for your API. And so while typical REST APIs require to make requests into many resources, GraphQL allows you to combine all of those requests into one. And this is just a quick example of how GraphQL query might look like. And so you might want to ask for specific fields on an object. You could provide variables for making the query dynamic, and the response would match exactly the shape that your client requested. And so this is compared to the REST APIs, essentially removes all the issues like migrations or versioning, because the client in this case is receiving exactly the data that it needs. Another approach is to reuse your JavaScript components on the server side, and this is where server-side renderings come into play. So React comes with this render-to-string method that allows you to render your front-end components on the server. And Pipelines investigated this approach a couple of times. However, we decided to not do it, at least yet. And the reason for that was that the overhead of maintaining a separate server for rendering components outweighed the benefits coming from it. It is great for SEO, though, and for more static websites. And so it also might work better for you. So I would, at the very least, look at it. And again, service workers. So explaining them actually would probably take a separate presentation, and because they're a little tricky to set up and to grab your head around that. But they are really powerful, and they're often used for things like handling poor internet connection or offline mode. They allow you to send push notifications, even do server-side rendering that I just mentioned. In the second part of my presentation, I will talk about measuring and optimizing your add-on. We can't be focusing on optimizing all the time, because we also need to build some features. And premature optimization is often a waste. So we only want to do as little as is necessary. One of the most important metrics that we look at is called AppDex. And AppDex describes it's a way to measure user satisfaction based on the response time of your application. It's a good insight into how satisfied your users are. And the way it works, you choose the arbitrary response time that you want to target for. And in Pipeline's case, it's 1 second, which is backed by the research and is also very easy value to measure against. And simply, if your page loads below 1 second, your user would be satisfied. If it loads between 1 and 4 seconds, your user would tolerate that. And if it loads after, longer than 4 seconds, your user would become frustrated. And the formula looks like this. So you take the number of satisfying requests summed by the half of the number of tolerating requests, and you divide that by the total number of requests. And an example of that would be if your application has 200 requests, 170 of those requests take less than 1 second to load. 20 out of those requests take between 1 and 4 seconds to load, and the remaining 10 requests takes more than 4 seconds, so you just disregard them. And so you divide that by 200, and you get 0.9, which is your Updex score. And 0.9 is actually very good value that with 1 second response time usually indicates that you're doing things right. First meaningful pain is the time when the page primary content first appears on the screen. And you can measure that through the Chrome developer tools. And you could measure the time as well as look at the screenshots. And as you can see in this example, Google search results optimizes for showing the search box first. Performance budget is a quantifiable target for how fast a website loads. This can be in the form of a goal for HTTP requests, page weight, or the total response time, or any combination of those. And a good idea would be to have automated tests that check against your application whether you're actually matching this budget. And so you could have, for example, part of your CI pipeline, a test that tests whether your JavaScript grew too much and then failed the test. There are a number of tools that allow you to measure that and test against and allow you to get more insights into the application performance. So there are two that I would recommend looking at. Lighthouse is an open source tool that just looks at the quality of websites. It's a Chrome extension as well as command line utility. And it can run against your website. It just gives you audit on your performance and a lot of other information. And Chrome DevTools is de facto standard for measuring front-end performance. It gives you countless tools from throttling your internet connection to looking through your network and digging down into how fast your resources get loaded. It allows you to profile your JavaScript. And the interesting thing that not many people know is that you can use that not only with Chrome, but pretty much with any other browser, because this is effectively a separate application that you can connect to your Firefox, Edge, or Safari. Lastly, for the purpose of this presentation, I've created a Chrome extension that gives you some basic information about your add-on performance. And I would repeat this URL at the end, or you could just type Connect Analytics into Chrome Web Store, and that would come up. And basically, what it gives you is if you have it installed in your Chrome and you open the console, it will tell you how fast the Connect add-ons loaded on that page, and it works for all of the Atlassian Connect products. So it also gives you some additional information, like what context parameters are provided to the add-on during the load time, which might be useful for debugging or just way for just useful information in general when developing your add-on. Finally, let's dig a little deeper into the Webpack. And so what is Webpack? Webpack is a module bundler for modern JavaScript application. And Pipeline, similar to many other bigger front-end projects, is using Webpack for building its UI. Although you could use the same techniques with other tools like Gulp or Grant, Webpack is by far the most powerful at the moment, and also it's very flexible. And so it could help you with some things like just optimizing your resources, just handling caching, and it removes the dead code and primarily it allows you to do code splitting that I'll be talking in just a moment. Okay, so Webpack configuration is the main file that Webpack requires for it to work. And so the way Webpack works, it creates the graph of dependencies of your application, and it needs to know where to start. And the starting point is the entry property in this configuration file. And this is just you can think of like a contextual root of your application. So this is the first file that you want your application to load. And so it usually contains references to all of the other modules. When you provide the entry point, you also need to provide the output. So this is the bundle that would get generated after the processing is done. Loaders are another core concept of Webpack, and they transform files into modules as they are added to the dependency graph. And so Webpack understands only JavaScript, but through providing loaders, you could also bundle different kinds of files, like CSS or images, but also things like CoffeeScript, TypeScript. Pretty much everything is available, and if it isn't, writing your own loaders is pretty easy too. And so Webpack not only can output also JavaScript, but it could also output a number of other files like images or CSS. So it's really great tool for bundling all of your assets that are required in your application. And loaders execute transfer on a per file basis, but sometimes this is not enough, and this is where plugins come into play. So plugins extend the capabilities of Webpack and can perform actions on the finished bundle, but they're not limited to it. So there are a bunch of other useful things that they can do, and I would give you some. I would give you examples of which plugins Pipelines is using in just a moment. For those of you that haven't used Webpack before, and so this might be a typical progression of how you'd use Webpack in your project. You could install Webpack as an NPM module, and like the simplest thing, you could provide the entry point and the output point as the arguments for the command line tool. And so that would process it to the bundle.js file. And it would bundle your application into one file, but it might be like it's very simple, and it might be really good in very simple projects like personal projects and perhaps maybe HTTP1 situation that I told you should avoid. But in a real project, however, you would often find that this bundle.js grows often to, when you start adding additional dependencies like React or Lodash, this bundle.js would grow into megabytes, which isn't good, as loading a megabyte of JavaScript on every single page load would cause performance issues, and we would get back to the square one where we started. Thankfully, Webpack is here exactly for this reason and help you manage this situation. And so you'd start with creating the configuration file that I was just talking about a moment ago, and you could split your app, for example, into two parts. Into vendor and application. So vendor would contain all of the dependency, for example, that you use, and application, the other part would contain the code of your application that presumably would change more often. And by doing so, you can isolate infrequently changed parts of your code, like vendor files, that compared to the application that might be changing more often. And so that means that the vendor file would be cache invalidated only when the dependency of your code would change. And if you write a React application, the vendor file would probably be the most of the JavaScript of your code anyway. So this seems like a good optimization. And this might be enough for a medium-sized application. However, when it grows into a big project, that is not enough, because your application starts growing into megabytes again, and we are back at the square one. Thankfully, however, Webpack has this feature called code splitting that solves this exactly issue. And so the way code splitting works is you can create a code split simply by using the import keyword in your JavaScript, and that would mean that it would import the module that needs to be code splitted. And when Webpack processes your modules and it encounters this keyword, it creates a split in this point, which results in a separate file. So that split would produce a separate JavaScript file that contains this module and all of the modules that this module that we want to code split contain. And by picking logical splits in your application, you can begin to chunk down the page weight and without introducing huge amount of complexity. And so these splits are often based on the user interactions. For example, if you have multiple pages in your single page app, you could create splits that for every single page. So if you change the URL, a new JavaScript would get loaded asynchronously, and this is where this split would get executed. Or for example, when you want to open a dialog, like there is no reason really why you want to load the JavaScript for this dialog before user even click that. So this allows you to do that. And the nicest part of this is that it greatly helps with caching, as only the files that you change, only those chunks that you change would get cached invalidated. And so if we go back to this example of a dialog, if you only work on the dialog, only the dialog JavaScript would change. And so when you deploy the next version of the dialog, everything else would remain, would still be in cache. And so this is good for performance. Deciding how to split your application can be a little tricky, and so this requires a little getting used to. The typical way Webpack handles invalidation is through adding the content hash into the file name. So this is for the cache busting that I was talking about before. As you can configure that in the output section of your Webpack configuration file through adding the chunk hash parameter to its file name. And so Webpack will now generate a bundle with a unique hash based on the content of the file of the bundle. This means, again, whenever we change a section of our app, only this chunk would change. And together with code splitting comes new web standard in form of link preload and link prefetch. So preload is a declarative fetch that allows you to force the browser to make a request for a resource without blocking the document onload event. And prefetch is a hint to the browser that this resource might be needed in the future, and so it optimizes when it wants to request that. So prefetch is good for things like asynchronous code loading, like the URL changes. And by adding those tags to your HTML, you could further improve the performance of your application. And this is also how you could notify the server that this is the resource that you want to be pushed. And so, for example, if you add the link preload to the JavaScript and your server supports HTTP2 with push, you could only request the index.html, and the server would return with index.html and the JavaScript files that you identified as the preload files. There are additional benefits related to this new spec that include setting resource priority, like checking security policies or advertising browser support for different kinds of files. And this is an example of preload in action. And so what you can see is that all of the script got downloaded and parsed at the same time, saving hundreds of milliseconds of waiting time. And I know that this might be rather quick and broad overview, but hopefully I just gave you some useful information to investigate further. If we have time, I'll take some questions. I have one-on-one that you can book still, or alternatively, just come and talk to me later after that. And so just wrapping up the Webpack section, let me briefly show you some of the plugins that Pipelines is using today. First being Bundle Analyzer, that allows you to scan the size of your dependencies of your bundle. And so this is really cool because you can clearly see which modules take the majority of the time. You could you could compare different dependencies based on the size, or it could also tell you, for example, that this moment library that you're using for parsing the date in this one place is actually adding a megabyte of JavaScript into your application. Preload Webpack allows you to automate creation of this link preload and link preferred script tags that I was just talking about. It essentially does all of the magic for you. Optimize.js is an interesting one. It's a JavaScript optimizer that adds to your already optimized bundled code specific JavaScript engine optimizations, and it usually works by wrapping all immediately invoked functions or likely to be invoked functions in parentheses. And so, like this, you might try it out if it works for you, if your JavaScript ends up being more performant. It's really easy win without doing much work. SW precache is similar to preload, and it automates creation of service workers. Lastly, the HTML Webpack plugin simplifies creation of HTML files to serve your Webpack bundles. And it is very customizable, so you could provide your own template that is specific to your application. And it combines very nicely with this code-splitted, generated code that we were just talking about a moment ago. Lastly, if I didn't convince you to take a look at Webpack yet, let me tell you that I barely scratched the surface of what it can do. Some additional benefits coming from Webpack. It allows you to do tree shaking, and tree shaking removes the unused code, and it produces smaller bundles. Hot reloading is really cool for development, which allows you to work on your application, and as soon as you change your code, it gets automatically replaced in the browser, so you can see the changes immediately without refreshing the browser. And lastly, Webpack is a huge open source project, and it has great ecosystem. It has lots of plugins, and there are many tools available that extend its functionality, and the documentation is great. And so I would strongly encourage you to at least have a look at it. Okay, so again, I barely scratched the surface of what you can do to speed up your add-on. Hopefully, however, I gave you some indication that between caching, HTTP2, and bundle size, those things matter and can greatly improve user experience. And while doing everything might be an overkill, I would suggest at the very minimum investigating the performance of your add-on to find out what quick wins apply in your context. And that brings us almost to the end. So we started with the spinner, and let's go back to it. And so the question remains, is there still spinner when loading pipelines pages? And the answer is no. Okay, there are still few edge cases like very slow internet connection with a slow cache or old mobile devices, but in majority of the cases, there's no spinner. And also Connect, to its credit, gave you some allowance before the spinner becomes visible. And so it makes your add-on feel more like an integral part of the product. And what we found out is that by maintaining an updex of above 0.8, there is no spinner. And in reality, this is the only chart and number that we looked at. And so if we drop below the line, we simply looked at, OK, what happened in the last few deployments, and iterate on top of that to just bring ourselves back above this line. And by doing this and applying some of those techniques, you too can make your add-on load super fast. They work well for pipelines, and they make pipelines feel like an integral part of Bitbucket. And surely they can work well for your add-on too. Thank you very much.